Hello and welcome to Nikolay's genetics lessons, and today we are going to talk about water potential and hypertonic, isotonic and hypertonic solutions. And here is the first question. A plant cell is found to have a solute potential of minus 0.5 megapascals and a pressure potential of plus 0.3 megapascals. If the cell were placed in a larger beaker containing a solution at atmospheric pressure and with solute potential of minus 0.4 megapascals, how does this solution relate to the cell? And here is the formula: psi W, which is water potential, equals to solute potential plus pressure potential. In our case, water potential would equal to solute potential minus 0.5 plus pressure potential 0.3, and we are going to get minus 0.2 megapascals, which is water potential. One more time, psi S stands for the solute potential, psi P stands for the pressure potential. So solute potential plus pressure potential, and this is how we get water potential. And we have found that inside the cell, water potential is minus 0.2 megapascals. Now I want you to take a look at this picture. Take a look at this left part, which represent pure water, and pressure potential is 0, solute potential is 0, so water potential here is also 0. We cannot get positive water potential, maximum 0 water potential for pure water. Now let's take a look at the right part. So we see here solute, and pressure potential is going to be the same, 0, but solute potential is going to be minus 0.4. More solutes in the water, then more negative this number is going to be. And the total water potential, as you see, would be minus 0.4. So total water potential is just pressure potential plus solute potential. So this is how we get this number. Let's also change this left part, because we know that inside the cell, solute potential is minus 0.5 and pressure potential is plus 0.3. So when we add these two numbers, we are getting water potential, which is minus 0.2. And according to these numbers, of course, inside the cell, we don't have a pure distilled water, but instead we have also here some solutes. But still, when we compare water potential of the cell and water potential which is outside the cell, we see that water potential is more negative. That means that water would go in this direction. Water flows in the direction where water potential would be more negative. So we can change this pure water to cell. And this left part represents cell. So what represents outside of the cell can be in three states. Hypertonic, what we see here, when there are more solutes in this solution than inside of the cell. Can be hypotonic if solutes here would be more diluted in comparison to what we can find in the cell. And also can be isotonic if concentration of the solutes is going to be the same. But also don't forget that in our formula we also have psi P, which stands for the potential pressure, so it also plays a role. And again, this is simplified formula. In more expanded formula, we have more forces, like for example gravitational force. Now we are ready to answer the question, but here is a trick. If you compare solute potential only, you will find that what we see inside the cell in comparison with outside the cell, pressure potential inside the cell would be lower. So for the cell, outside solution would be hypotonic. But this is not how we compare. Here we compare water potential of the cytosol inside the cell and solution outside the cell. And we see that outside the cell, water potential is more negative. So that means that water would flow from the cell to the outside cell. And for the cytosol of the cell, solution outside of the cell would be hypertonic. And this is answer C. And this means we also gave an answer to the second question. In this solution, what would happen to the water? Assume that no solute can cross the plasma membrane in either direction. And we already know that water would leave the cell. Answer B. Take a look at this picture. And the first picture represents isotonic solution, and nothing is going to happen because water potential of the isotonic solution is going to be the same as inside the cell. So they just would, water can freely diffuse back and forth. If we place a cell in the hypotonic solution, that means that water would go inside the cell. And that means that water potential of the cell would be lower than of the outside. If water potential outside the cell would be lower than inside the cell, then water would go in the outside solution, and we call such solution hypertonic. And this is exactly what we got. Inside the cell, water potential is minus 0.2 megapascals, outside minus 0.4 megapascals. So water would flow from the cell to the outside hypertonic solution. And what is going to happen to pressure potential? Pressure potential, instead of being positive, now would be negative. Compare with pressure potential, for example, here, which is going to be positive number, like here, and here, which is going to be, in this case, negative number, negative pressure potential. So this is our choice. Water would leave the cell into hypertonic solution. And this is all for today. Subscribe and see you in the next video. Goodbye.